So welcome to this video. We'll be going over the October-November 2021 Pure 1 Paper 1 Variant 3. Let's go. So for question 1, we have the graph of f of x is transformed to the graph of y equals 3 minus f of x. Describe fully in the correct order the two transformations that have been combined. So the first transformation, that will be the minus f of x. So what is that minus f of x? Well, there's two ways we can describe it. Now, the easiest way is what we can say is, because that minus is outside the f of x, okay, it is going to be stretched. So if I just write it here, it will be stretched by a scale factor of a minus 1 in the y direction, okay? So that is the first transformation. Now, equally, when you have minus f of x, that is actually the same as reflecting in the x-axis as well. So you could also say that it is a reflection in the x-axis, but I'll write it like this: stretched by a scale factor of minus 1 in the y direction. So that is the first transformation. And the second transformation, well, that is that positive 3. Now, what does a positive 3 mean? That means that with the graph, it's being shifted up by 3 units. Now, the easiest way when we're dealing with shifting up, down, left, right by a certain amount of units is it's translated. So we can write a translation of, and then it's being shifted upwards. So that would be a 0, 3, okay? And we are done. That is all we need to do for the 4 marks. Okay, so as you can see, it's a very nice, generous question. You get 2 marks for each of your points. And it's fairly simple to do for the 4 marks. For question 2, we need to find the first 3 terms in ascending powers of x in the expansion of 1 plus ax to the power of 6. Okay, to do that one, if we do the binomial expansion, well, we start with 6 choose 0. Now 6 choose 0, that will be times by 1 to the power of 6. Now I can just write 1, but I'll keep it as 1 to the power of 6. And that's times by ax to the power of 0. Okay, so that'll be the first term. The second term would be a 6 choose 1. That'll be times by 1 to the power of 5, which will then be times by ax. And then the last term we want, that would be a 6 choose 2. That will be times by 1 to the power of 4, which would then be times by ax all squared. Okay, and if we work this out, what do we get? Well, we get, for the first term, 6 choose 0 is just 1, and then a 1 to the power of 6 is just 1, a to the power of x to the power of 0 is just 1, so first term is just 1. Second term is 6 choose 1, which is 6, times by 1, times by ax. That would give me a 6ax. And that last term, 6 choose 2, that is a 15. So we get a 15, and then a 1 to the power of 4 is 1. Ax all squared, that will give me an a squared x squared. Okay, so that's 2a done. And for part B, we have given that the coefficient of x squared in the expansion 1 minus 3x times by 1 plus ax to the power of 6 is minus 3. Find the possible values of the constant a. So for this question, if we start with 1 minus 3x, and we need to multiply, well, by that 1 plus ax to the power of 6. In the previous question, we worked out those terms up to x squared, okay? Therefore, we can replace the 1 plus ax squared with a 1 plus 6ax plus a 15a squared x squared. That's what we worked out in part A. And the reason we can do it is because we care about the x squared coefficient, okay? The x squared coefficient, that is what tells us, if we can work out the x squared coefficient, that will help us form an equation and work out a, which we can do now, because looking at what we have here, well, if we have this 1, okay, now we could multiply by just the 1 times 1. We can also multiply the 1 by the 6a to the x. But again, that doesn't give us an x squared coefficient. What will is if we times that 1 by the 15a squared x squared. Now, same with the minus 3x. We can times by 1, but that'll just give us a minus 3x. We can times by the 15a squared x squared, but that'll give us a minus 45a squared x cubed. But we only care about the x squared coefficient, so therefore we have to times by the 6a to the x. So what we're going to do is we're just going to multiply these values, which will give us an x squared coefficient. So if we do 1 times the 15a squared x squared, we get a 15a squared x squared. And if we do the minus 3x times by the 6ax, we get a minus 18a x squared, okay? And we know that the x squared coefficient must equal minus 3, so then therefore this will equal a minus 3x squared. Now at this stage we can get rid of our x squared, and we know that 15a squared minus 18a must equal a minus 3. So therefore if we move that minus 3 to the other side, we get 15a squared minus 18a plus 3 is equal to 0. And now we can just divide by 3. So we get a 5a squared minus a 6a plus a 3 is equal to 0. And now we have a nice quadratic equation. Oh, wait. And I forgot that, my bad. This should be a positive 1 equal to 0. Now we have a nice quadratic equation. And now at this stage, if we just, well, we get a 5a here, we're going to have an a here. Think of two numbers. Well, it has to be 1 and 1 because we have a positive 1. And it has to be, both of them have to be negative 1 because that's how we can get a negative 6a. So we get a 5a minus a 1. A minus a 1 is equal to 0. Therefore, we can see that our two values for a would be 1 over 5 and 1. Question 3, we need to express 5y squared minus 30y plus 50 in the form of 5 times by y plus a squared plus b, where a and b are constants. So for this one, first thing we can do, okay, is we can, so take out a factor of 5, so we get a 5, then in brackets we get a y squared minus a 6y plus 10, okay? And then once we've done that, therefore we would get we need to complete the square, so we get a 5, then in brackets we'd get a y minus a 3 squared minus a 9 plus a 10, okay? And therefore we'd get a 5 in brackets y minus a 3 squared plus 1. And therefore we need to now times everything by a 5. If we do that, we'd get a 5 y minus 3 squared and then 5 times 1. So we get a plus 5, and therefore we are done, where in this case a would be a minus 3 and b would be 5. For part b, we have that the function f is defined by f of x equal to x to the power 5 minus 10x cubed plus 50x, and we determine whether f is an increasing function, a decreasing function, or neither. So the first thing to note, what is an increasing function or decreasing function? Well, if f dash x, okay, if that is greater than 0, therefore it is going to be an increasing function. And if f dash x is less than 0, it's going to be a decreasing function, okay? So that's what we need to figure out. So first things we need to do is we need to differentiate f of x, okay? So if we differentiate f of x, we get f dash x, well, that would be 5x to the power 4 minus a 30x squared plus a 50, okay? And now we need to determine whether this will be this will be greater than 0 for all values of x, for all real values of x, or would it be less than 0 for all real values of x? Now, one thing to note is this question looks very familiar to part A, okay? Like part A, we had 5y squared minus 30y plus 50. Now, to signal this even more, what I'm going to do is I'm going to do the substitution method. I'm going to let y equal x squared. And by doing that, what do we get? Well, now we end up with a 5y squared minus 30y plus a 50. And this is the exact equation we had in part A. So what does that mean? Well, in part A, we complete the square, right? We worked out that 5y squared minus 30y plus 50, it equaled 5. Then in brackets, it was x, or in this case, let's say y minus 3 squared plus 5. So therefore, we know of our question, if we put back in the x squared now, we have that 5x squared minus 3 all squared plus 5 would be the exact same. And now what we need to do is determine, well, for all real values of x, would this be less than 0 or greater than 0 or just neither, right? So looking at it, well, what do we have here? We have a squared value in that middle, okay? We have that x squared minus 3 all squared. Now we know that anything all squared, we know the x squared minus 3 squared will always be greater than 0 for all real values of x. Now, why is that? Because it doesn't matter what value you have for x, if you square it, it's going to be a positive value. Therefore, we know that that will always be a value greater than 0. Therefore, if we times by anything greater than 0, 5 times a positive value will always be greater than 0. And so therefore, because that will be greater than 0, we know that 5x squared minus 3 will also always be greater than 0 for all real values of x, okay? And therefore, by that, if we're always going to plus 5, well, we know that 5x squared minus 3 squared plus 5, that's actually going to be greater than 5, which in turn is also going to be greater than 0 for all real values of x. Therefore, what do we know? Well, we know that f dash x will always be greater than 0 for all real values of x. Therefore, we can say that it is increasing, okay? It is increasing, because it doesn't matter what value you have for x, that it will always be greater than 0. Question 4, we have the first term of an arithmetic progression is 84, okay? And with the common difference is a minus 3. Find the smallest value of n when the nth term is negative. So one quick thing about this is just be careful. We see that it's 84, and we know that we're going to subtract 3 each time. So you may think, oh, well, 84, we can just divide by 3, right? That will give us a value. And we know that we can just keep going until we get to 0. And if you do 84 divided by 3, you get 28, right? So you may think, oh, 28, then the 28th term is 0. It must be the 29th term, right? But you'd be wrong. Because you'll be careful, remember, the first term in this is an 84. So it wouldn't just be 28. The 29th term would actually be 0. Therefore, the 30th term would be the first negative term. But this is why I think even with these questions, even though it seems fairly simple, still write out the equation of an arithmetic sequence first, and then from there, then it will always just be easier for you. So even for this question, what I'm going to do is, we know a1 is equal to 84. We know our d value is equal to a minus 3. And we know that the general term of an arithmetic sequence, the general nth term, is an is equal to a1 plus a minus 1d, okay? And we know that in this case, we know that an is equal to 0. We know that we'll get some term which is equal to 0, so let's work out what that term is. So if an is equal to 0, then we can say that 0 is equal to a1, which we know is 84, plus n minus 1, and we know d is minus 3. And we can work out this term. And by doing this, we get 84, and we get minus a 3n plus a 3, okay? And if we rearrange this, we'd end up with a 3n is equal to an 87, therefore n is equal to a 29. So we get the 29th term at 0. We know that, use this pen, we know that a29, the 29th term is equal to 0, not the 28th term. And therefore, we know that, well, if we subtract a 3 again, that will give us our first negative number, which will be minus 3. Therefore, it's the 30th term, therefore n is equal to 30. Now, you're going to be careful of that. If you may think just to do 84 divided by 3 gives you 28, 28th term must be 0, 29th term must be minus 3. But actually, could we start with the first term as 84, and actually be that the 29th term would be 0, and the 30th term would be a minus 3. So sometimes, even if it seems simple, still work out the general nth term and go from there. And yeah, just to make sure you get the right answer. For part B, it is given that the sum of the first two k terms of this progression is equal to the sum of the first k terms. Find the value of k. So what that means is that the sum of 2k, of the first 2k terms, is equal to the sum of k terms. So we need to find an expression for when we have 2k and when we have k, equal them together, and we should be able to get a value for k, okay? So the general form for a sum of an arithmetic sequence is Sn is equal to n over 2, 2a1 plus n minus 1 times d, okay? That is the general form, okay? And in this case, we still have that a1 is equal to 84, and we have that d is still equal to minus 3. Okay, and we need to work out what these could be. So the first thing I would do is just formulate an equation in terms of 2k and then formulate another equation in terms of k and equal them together. So let's start off with 2k, okay? So if we have the sum of 2k, well, that would be 2k divided by 2, which is just k. And then we would have a 2 times a1, that's a 2 times 84, which is a 168, plus a n minus 1. Remember that in this case, n is 2k, so it would be a 2k minus 1. And then that would be times by d, which is a minus 3, okay? And then once we've done that, we just need to follow through. So we get a k, and that is equal to a 168. 2k times minus 3 is a minus 6k plus a 3. And then we have that a k that is equal to a 171 minus a 6k. Okay, so therefore we have that k is equal to a 171 minus 6k, okay? And we can leave it like that. We can expand it if we want to, but we don't need to for now. We can just leave it like that. And then we do the same for the sum of k. So the sum of k, that would be a k over 2. And in brackets, again, we get a 2 times 84, which is 168. Then we get a plus a k minus 1 times by d, which is a minus 3. And then again, we just do the same thing. So we get a k over 2, and then that's a 168 minus a 3k plus a 3. And then that will give me a k over 2, then in brackets, a 171 minus 3k. And again, we can just leave it like this. That is fine for now. So now at this stage, we can just equal them to each other because the sum of the first 2k equals the sum of k. So now I've made them equal to each other, and now we just need to work out this equation, okay? So first thing first, I'm going to multiply by 2 on both sides. So we get a 2k times a 171 minus 6k is equal to a k, or then a 171 minus a 3k, okay? And this stage, I'm just going to expand the brackets out, make it simple for myself. So by doing that, we get a 171 times by 2k, that is a 342k. Then we get a minus 12k squared, that is equal to a 171k minus a 3k squared. And then if I bring that 171 over to the side, we get a 171k, and that is equal to a 9k squared, okay? And then actually we can actually divide by 9. So if we do that, that will give us a 19k, and that is equal to a k squared. And if we bring everything to the same side, we get k squared minus a 19k, that is equal to a 0. And therefore factorize, we get a k minus 19, that is equal to 0. Therefore we get two values for k is equal to 0 and k is equal to 19. But obviously we can't have a 0 term here because the first term starts at 1. So 1 is that first term, k has to be greater than or equal to 1 in this case. Therefore we can disregard the 0 and we're just left with 19. Therefore k is equal to 19. So for question 5, we have that in the diagram, x and y are points on the line AB such that bx is equal to 9 centimeters and ay is equal to 11 centimeters. Arc BC is part of a circle with center x and radius 9 centimeters, where CX is perpendicular to AB. Arc AC is part of a circle with center y and radius 11 centimeters. And we just show that angle XYC is equal to 0.9582 radians, correct to 4 significant figures. Okay, so what we need to do is we need to show that this angle here is equal to the 0.9582. Okay, so let's call this theta. How can we show that's equal to that? Well, what do we know about the question? Well, if they tell us in the question that we have an arc BC with center x, okay? So with this arc here, BC, and it has center x, what does that mean? That means that this would be the radius of that arc. That also means that this would also be the radius of that arc, because they're on the same arc and they have that same center. Therefore, we know that this length here, BX, must be the exact same length as CX, okay? Therefore, we know that this, if BX is equal to 9 centimeters, we know that this is also 9. And then the same with the other arc. If we have the other arc here, AC, okay? We have AC here, and we're told that AC, that has the center Y, which tells me that AY must be the same as CY, okay? Because they're on the same arc and Y is radius. Therefore, if AY is 11 centimeters, that means that CY also has to be 11 centimeters. And this is a right angled triangle. So we know that this is the hypotenuse. This would be the opposite. And we can just use SOHCAHTOA now to work that out. So if we use SOHCAHTOA, well, if I do it over here, we have that sine theta is equal to the opposite over the adjacent. So that, opposite over hypotenuse, so that would be 9 over 11. And if you do the inverse sine of 9 to 11, make sure you're in radians, you will get to 4 significant figures, 0.9582 radians. So for part B, we need to work out the perimeter of ABC, okay? So perimeter of ABC, so we need to work out the length of this arc AC, the length of this arc BC, and then the length of this straight line AB. So let's start off with working out the two easier lengths, which is the arc BC and arc AC. So to work those out, fairly simple. So if we look at the arc BC first, okay, well, how can we work that out? Well, we know what is the arc length, okay? We know the equation is length is equal to r times theta. Now that's fairly easy because we know that what the radius is. We know the radius is just 9, okay? So it will be a 9. And for the theta value, well, at first, it may be like, what is the theta value? But remember that it's arc BC, okay? So if I get this right now, if this is the arc and this is this angle here we're looking at, okay? But as we can see, this is a right angle. So what does that mean? Well, that means that this right angle, that would be theta for length BC. Now, what is a right angle? What is 90 degrees in radians? That's just pi over 2. So that would just be pi over 2. Therefore, for theta for the arc BC is actually 9 times pi over 2. So therefore, we get the length of BC as being 9 pi over 2. Okay? And for AC, arc AC, well, again, that's still length times r theta. So we have length is equal to r, which we know is 11. And for this one, well, now, for this one here, okay, we are going to use this angle here. So that's the angle XYC. And that angle, which they tell us in the previous question, okay, that is 0.9582. And if you work that out to, let's say, 2 decimal places, you get a 10.54. So we know that this length here, this arc length, is 10.54. Now all we need to do is work out what this length of AB is, okay? So to work out the length AB, all we really need to do is if we can work out the length of XY here, that will help us work out what the full length of AB is. So how can we work out what that XY length is? Remember the previous question, okay? We worked out that CY was 11 and CX was 9. So we can just use Pythagoras' theorem to work out what XY is. Remember, it's a right-angled triangle. So we have something like 9x, not 9x, we have something like 9 squared. And if we let's call this A, we have 9 squared plus A squared is equal to 11 squared, okay? Therefore, we have that A is equal to the square root of 11 squared minus 9 squared. And if you work that out on your calculator, you would get 2 root 10. So what do we know? We know that in this case, A would be a 2 root 10. So we know that this value here would be a 2 root 10. XY is 2 root 10, okay? This is 2 root 10. And now we have that the total, we know that if we add the 9 plus 11, we get a 20. So it would just be the 20, and then we can just minus 2 root 10, and that should give us our answer. But if you didn't know that, I mean, you could also, what you could do is you could also like write all your different measurements. Like you could work out AX. So AX would be like 11 minus a 2 root 10, and then YB would be a 9 minus 2 root 10, and then just work out the sum of all of that, which will again give you 20 minus 2 root 10. Okay, so it's up to you how you want to work it out, but effectively, by doing it like this, you get the sum of AB, or the length of AB would be a 20 minus a 2 root 10. So now we've worked all that out. Okay, we now know that the whole of AB is 20. If I write it here, 20 minus a 2 root 10. Well, it's fairly simple now what we have to do. If we just add up everything, so 9 pi over 2 plus a 10.54 plus a 20 minus a 2 root 10. Put that onto your calculator, and then to 3 significant figures, you get a 38.4, okay, to 3SF, okay, and that would be the perimeter. So for 6a, we have that this diagram, it shows a graph of y equals f of x, and on this diagram, we need to sketch the graph of y equals the f of minus 1x, okay? So what is f of minus 1x? Well, that's just the inverse of f of x. And when we deal with the inverse of f of x, okay, that is going to be a reflection in the y equals x line, okay? So what would that look like? Where was reflection in the y equals x line, then kind of think of everything is being flipped in that kind of y equals x line. So thinking about that, in my head, I just think about what that will look like if I was to flip everything. If I was to flip everything like 180 in that y equals x line, well then this would be over here now, and this would be over here now in that reflected line. So I'm feeling like this, if you reflect it, it's gonna have like kind of, I don't know, like it's kind of an R shape, but like the other way, right? And then this, when you flip it, it's gonna have more of like an L kind of shape, okay? So what I mean by that is it's gonna look something like this, okay? So it'll be something like this. It'll go through the origin, and then it will be something like this, okay? A rough drawing, but it will look something like this. And then that would be the y equals f of minus 1x line, okay? And for part B, we now need to, given that f of x is equal to minus x over the square root of 4 minus x squared, where x is between minus 2 and 2, we need to find an expression for f of minus 1x. So pretty much we need to find the inverse of f of x. So what I would like to do is I would make f of x, just make it equal to x, and that will give me a minus y over the square root of 4 minus y squared, and then I'm going to rearrange this for y to get my value of the inverse. By doing this, I'm going to multiply that square root, so we get x times by the square root of 4 minus a y squared, okay? And that would equal a minus y. Then I'm going to square both sides, so we get the square root of 4 minus y squared, all of that squared is equal to minus y all squared. So that'll give me an x squared, and that's times by now just 4 minus y squared. And that's equal to a y squared, a positive y squared. And now we get that a 4x squared minus x squared y squared is equal to a y squared, okay? And then I'm going to leave that 4x squared here, and then we get a y squared plus an x squared y squared, okay? Now if I just flip the sides, okay, so let's move it to y squared plus x squared y squared is equal to a 4x squared. And now if we factorize out the y squared, we get a y squared 1 plus x squared. That equals a 4x squared. And now we get a y squared is equal to a 4x squared. And that is over a 1 plus x squared. Therefore, our y value is equal to a plus or minus the square root of a 4x squared over a 1 plus x squared, which we can actually work this out because the square root of 4x squared over the square root of 1 plus x squared, that would, remember this is all plus or minus, that would be plus or minus, well, the square root of 4 is 2, and the square root of x squared would just be x, okay? So we get plus or minus 2x over the square root of 1 plus x squared. But are we done yet? No, we're not. Because with these type of questions, we have a plus or minus 2x over the square root of 1 plus x squared. But the inverse of f of minus 1x can only be one of those values, okay? One of those, you can consider it an extraneous solution. So how can we determine which of these values is correct? Is it going to be a plus or a minus 2x over the square root of 1 plus x squared? So what I would do is go back to your graph. As we can see in our graph here, what does this look like here? Well, if we look at our graphs here, if you look at the values of when x is positive, right? So these values here, when x is positive, what do we get for y? Well, when x is positive, right? When x is positive, y is negative, okay? And the same happens when x is negative, y is always going to be a positive value, okay? Because looking at our graph, when we have any negative x values, we are in this quadrant here, and y is always positive, okay? Y is always positive. When x is positive, y is always negative. So when we have our question here, where we have plus or minus 2x over the square root of a 1 plus x squared, well, if we think about values for x, okay, if let's say we look at positive 2x over the square root of 1 plus x squared, well, if we take, let's say, a positive value for x, right, let's take 1. Let's just take 1, right? So let me just draw on, let's say this is x equal to 1. Well, we know that this value here, it will be here, right? So if x is equal to 1, then our y we should get a negative value for our y, because remember that this is y, okay? So we should get a negative value for our y. So therefore, if I think about that, well, if we think about x equal to 1, for example, therefore we would get a 2 times 1, which is 2, over a 1 plus a 1, so that gives me a 2 root 2. Now that gives me a positive. So in theory, when we use x equals to 1, we should get a value in this quadrant here. Because when we use the positive 2x, right, we get a positive value for y. So really, we should get a value in this quadrant. But our graph is not in this quadrant. So therefore, that doesn't seem right, okay? Now let's do the same thing. But let's do the same thing now for when y is a negative 2x over 1 plus x squared, the square root. So now if we take that same value of 1, if we work that out, we get a minus 2 times 1, which is a minus 2. And over the same thing, a 1 plus a minus 1 squared, that will still give me a root 2, right? Well, now we get a negative value, which would therefore be in this quadrant here. So therefore, by looking at our graph, we can just work out which of these values are right just by doing a bit of trial and error and just looking at it. That we know that if we have a negative value, if we have a positive value for x, okay, we know that that should give us a negative. The only way we can do that is if we use the minus 2x, and vice versa. If we use a negative value, well, a negative value would be the negative times a negative. It would give us a positive y value. Therefore, it would be in this region as well. Therefore, we know our answer must be this value here. It must be a minus 2x over the square root of 1 plus x squared. For part C, we have the function g is defined by g of x equal to 2x for minus a, which is less than x, which is less than a, where a is a constant. State the maximum possible value of a for which fg is formed. So, for which fg is formed. So, if we have f of g of x, okay, and we know that g of x is 2 of x, so that's the same as saying f of 2 of x, okay? Now going back to our question here, we are told that for f of x, we have x between minus 2 and 2. So x is between minus 2 of 2. So when we had f of x, okay, the domain was between minus 2, which is less than x, which is less than 2. If we have f of 2x, well, what's happened to the domain of f of 2x? What's the transformation for this? That's a scale factor of a half in the x direction. Therefore, we need to multiply everything by a half. So therefore, it would now be, if we half all our values, we get minus 1, which is less than x, which is less than 1. So now, f of 2x, the domain is now between minus 1 and 1. They want the maximum possible value for a, for which fg is formed. Well, it's between minus 1 and 1. 1 is the biggest value we can get. Therefore, a is just 1. And for part D, assuming that fg can be formed, find and simplify an expression for fg of x, okay? So again, we know that fg of x, that is the same as f of 2x. So therefore, we just need to put 2x into our equation of f of x, and that should give us our answer, okay? So what is f of x? So we know that f of x, okay, we know that f of x was a minus x over the square root of 4 minus x squared. So now if we know that, well, now we just need to substitute in 2x for whatever x was. Therefore, f of 2x is equal to a minus 2x, okay? And that is over the square root of 4. So be careful of this one. Minus the 2x all squared, okay? Just be careful of that one. Don't just do 2 and then x squared. You're going to lose a value. It's 2x, all of that is being squared, okay? So therefore, that is a minus 2x, and that is over the square root of a 4 minus a 4x squared. And what we can do here is we can actually take out a factor here. So we have minus 2x, and then that is all under the square root. And what we can do, we can take a factor of 4 here. That gives me a 1 minus an x squared, okay? And therefore, because we've done that, that will give us, if we simplify that down, we get a minus 2x, okay? The square root of 4 is just 2, so we're left with a 2. And then that would be the square root of 1 minus x squared. And then we can cancel out the 2's, okay, because 2's cancel out here. So we're left with a minus x, and that is over the square root of a 1 minus x squared, okay? And we can leave our answer like that. So for 7a, we've got this trig equation here, tan x plus cos x over tan x minus cos x equal to k. K is a constant. We need to show that it can be expressed in this form below here. Okay, so what I'm going to do is I'm going to do tan x plus cos x. I'm going to bring the denominator to the other side. So you multiply by it. So we get a k tan x and then minus a k cos x, okay? Now what I'm going to do is I'm going to group all my terms together, all my cos terms together, and then all my tan terms together. So by doing that, I'm going to bring my cos to the left, so we get a k cos x plus a cos x, okay, and that would equal a k tan x minus a tan x, okay? And now I'm just going to factorize. So if I think about factorizing this, I will get a cos x, and then I'll get a k plus 1 is equal to a tan x, and that would be a k minus 1, okay? So it's starting to take a bit of shape. But what can we do now? Well, now we have to use some identities, right? Because we know that we want everything in terms of sine x. Wait, and everything in terms of sine x. So we have a tan, right? Well, we know that tan x equal to sine x over cos x. So that's the first identity we want to use. So we're going to change that. So cos x times k plus 1, we're going to change the tan x to a sine x k minus 1 over a cos x. Okay, we'll just change the tan x into sine x over cos x. And now we can multiply by that cos x. So we get a cos squared x k plus 1 is equal to a sine x k minus 1. So right now we've got a sine x, but now we've got a cos squared x. And again, just remember the other identity, that a sine squared x plus a cos squared x is equal to 1. So by knowing that, we can rearrange that. So we know cos x is equal to a 1 minus a sine squared x. So therefore, for that cos x, we change it to a 1 minus a sine squared x. That's all being times by the k plus 1. And that's equal to our sine x. And that is k minus 1. And then we'll just expand the brackets out. So what do we get when we expand the brackets out? Okay, we get a k plus a 1. So we get the k plus 1. And then that's also minus sine squared x of k plus 1, okay? So I've just kept everything the same. And then once we've done that, that's equal to a sine x k minus 1. And therefore, just need to rearrange this. So we get a sine squared x k plus 1 plus a sine x k minus 1. And then if we bring the k plus 1 to the other side, then we get a minus k plus 1, which is equal to 0. So for part B, we need now to solve the equation of tan x plus cos x over tan x minus cos x is equal to 4. And we need to solve for x, where x is between 0 and 360. So we know from the previous question that a sine squared x, k plus 1, that is plus a sine x of a k minus 1, okay? That is minus a k plus 1, and that is equal to 0. We're told that in this case, we have 4, right? Now, in the previous question, it was equal to k. Now it's equal to 4, which means that k is equal to 4 in this question. So because k is equal to 4, we can just substitute that in. And what do we get? Well, if k is equal to 4, we would end up with a 5 sine squared x plus a 3 sine x, and then we would get minus a 5, and that is equal to 0. So now we're quadratic equation. Let's put a little substitution in to make it a bit easier. So let y equal a sine x. Therefore, we have a 5y squared plus a 3y minus 5 is equal to 0, okay? Now this was a bit difficult. We can't just, I guess, factorize it. We have to use either the completeness square or the quadratic formula. Let's use the quadratic formula, okay? So in this case, we would have that a is equal to 5, b is equal to a 3, and then a c is equal to minus 5. So we get a minus b. So we get a minus 3 plus or minus the square root of b squared, which is a 9, minus a 4ac. So that's a 4 times a 5 times a minus 5. So a minus 4 times a minus 5 is a positive 20, times a 5 is a positive 100. and that is over 2a. So 2 times 5 is a 10. And therefore, our two values would be a minus 3 plus or minus the square root of 109 over 10. So what does this mean? Well, this means that sine x, let's put back in sine x now, must equal either minus 3 plus the square root of 109 over 10, or it equals a minus 3 minus the square root of 109 over 10. Now, if you work out those values, okay, if you do minus 3 plus the square root of 109 over 10 on your calculator, you will get a 0.74, okay? And if you do the same for the minus 3 minus the square root of 109 over 10, you get a minus 1.34. Now, what does this mean? Well, we know that for sine x, okay, we know that sine x is always going to be, or any sine is always going to be between minus 1 and 1. Therefore, if we get a minus 1.34, we know that this is not a valid solution. Therefore, we can just disregard this because that's greater than 1, or it's less than minus 1. So we can just disregard it. Therefore, we only need to consider this value here, okay? And that's going to be positive because that will be a 0.74. So if we draw a cast diagram now, I draw my cast diagram here. Okay, and then a STC. Well, then if you do the inverse sine of minus 3 plus the square root of 109 over 10 on your calculator, you will get a 48.1. Okay, make sure you're in degrees. And that also means that we're going to get a 48.1 here because we want it when sine is positive. Those are the two regions where sine is positive, and therefore we want it between 0 and 360. Therefore, x value would be 48.1, and it would be 180 minus a 48.1, so that would be a 131.9 degrees, and those would be our two solutions. So question 8, we have this two curves, okay? One with equation y equals x to the minus a half, and the other with y equals 5 over 2 minus x to the half. The curves intersect at the points of 1 over 4, 2, and 4, 1 over 2. Find the area of the region between the curves, okay? So we need to figure out this region here. Now, to figure that out, we're going to integrate, okay? And integration is, when we integrate, when we look at the area, it's always going to be the area under the curve. So effectively, what you can think of in this question is it's always the area under the curve. So if we think about this line here, okay, this is the 5 over 2 line, okay? Think about that line between the points of 1 over 4 and 4. So if I just draw like a dotted line here, okay, let's think of this. If we think about integrating between 1 and 4 and 4, well, effectively, if we do that top curve, the 5 over 2 minus x to the half, if we integrate that, then the area under the curve would be all of this. That's what we're working out. We'll end up working out all of this here. And if we're to work out the area of the y equals x to the minus a half, well, under that curve, it would just be all of this. All of this. Therefore, if we want this value in the middle, it would just simply be the interval of between, we get 4 here and 1 over 4 here, of, it would just be, we start with the 5 over 2 minus x to the half, okay? And that's with respect to dx. And then we just minus the interval of, again, 4 and 1 over 4 of just x to the minus a half with respect to dx, okay? So we just do, that's effectively it. That's what we do. It would be, it's just because we know that it'll just be the area of one of them minus the area of the other one, and that would just give us our intersection here, which is what we want, okay? So that's what we're going to do. So let's start with integrating. So we get a 5 over 2, so that would be a 5 over 2x, okay? and then we get a minus x. Now we're gonna plus 1, so we get a 3 over 2, and then we're gonna divide by that. So that's a 3 over 2, and then just make sure we still have a limit here of 4 and 1 over 4. And that is minus x to half, so that's just x, and then a half over a half, okay? And then that would also be between 4 and 1 over 4. Okay, and if I just rearrange this, we get a 5 over 2x minus 2 over 3x to the 3 over 2. And that is a 4 and a 1 over 4 minus a 2x to the half and a 4 and a 1 over 4. So let's start putting in our values, okay? So let's start with the x equal to 4. So we get 5 over 2 times a 4. That's a 10. Because 5 over 2 times a 4 will give us a 10. And then if we think about 2 over 3, now we have the square root of 4, which is 2. So the power of 3 is 8. So it's minus 2 over 3 times 8. So it's a minus 16 over 3. Okay. So, and then if we do the same thing, but we put in 1 over 4, well, at this stage, I would say easy to put it onto your calculator. And if you do that, you get a 13 over 24. Okay. And then now let's do that second bracket. So for this one, 2 times a square root of 4, that's a 2, so we get a 4. And then if we do the same thing, we get a 2 times the square root of 1 over 4, which is a half. 2 times a half is a 1, so we get 4 minus 1. Therefore, we get 10 minus 16 over 3, minus a 13 over 24. If you just work all that out on your calculator, you get a 33 over 8. And then we also have that 3, okay? Because we do minus a 4 minus 1, so we have minus a 3. So therefore, we have 33 over 8 minus a 3, which is 33 over 8 minus a 24 over 8, which leaves us with a 9 over 8 as the area. For part B, okay, we have a normal to the curve at y equals x to the minus a half at the point 1, 1 intersects the y-axis at the point P, at the point 0, P, find the value of P. So this one's, for 4 marks, I would say is a pretty nice question because we're told the normal to the curve at this certain point intersects the y-axis at this certain point. So what we need to do is work out what the gradient would be at that point, and then just put 1 into x, which will give us a gradient, do the negative reciprocal, which will give us the normal gradient, and work out the equation of the straight line, because that will give us the form of y equals mx plus c, and whatever that c value is, that will be our y-intercept, which will be that point. So if we have y equals x to the minus a half, we'll differentiate that. You get dy over dx. That would be minus a half x to the power of 1 over 2. We put in our x value. Well, our x value is just going to be, it's just minus a half, 1 to the power of minus a half. So therefore, our m value is just minus a half. Therefore, our n value, okay, our n value, our normal gradient at that point would just be negative reciprocal. That's a positive 2. So if we get n is 2, we know that x is 1 and y is 1 because, well, those are the 2 points we have of intersection. We just need to put that into the form of y take away y1 is equal to n being the normal gradient, take away x1 here. Therefore, we get a y minus a 1 is equal to a 2, x minus a 1. We get a y minus 1 is equal to a 2x minus a 2. Therefore, y is equal to a 2x minus a 1. Worked out that equation. We know that intersects on the y-axis. Therefore, it's the c, whatever our c value is, whatever our y-intercept value is. Therefore, p is simply going to be a minus 1. So pretty nice for 4 marks there. So for the question 9a, we got that the line y is equal to 2x plus 5 intersects a circle with equation x squared plus y is equal to 20. We need to find the coordinates of a and b in third form and find the exact length of the chord AB. So if I just draw a circle quickly, what are they asking us to do? Well, if we have this circle here, okay, then what they're asking us to do is, we know that this circle is x squared y squared, okay? we know this circle goes through the origin, or the center is 0, 0. But we have these 2 points, so 2x plus 5. Now this intersects the, here's a straight line, it's going to intersect at 2 points, right? Now, because it's a 2x plus 5, therefore, what do we know about this question? Well, we know that if I just draw like maybe a dotted line like this, okay, this is like the y-axis, right? Then we know that it's going to intersect at 5, okay? So therefore, we know that it's going to intersect at some point, let's say let's say here, for example, right? Therefore, if we think about what that line would look like, it's got a positive gradient, it would look something like this, okay? So it's going to intersect at 2 points, like this. Let's say that's B, let's say that's A. That's where it's going to look something like this, okay? So those are 2 points going to intersect, and we want to work out the length of the chord. So all that means is once we work out intersection points, we just need to use Pythagoras theorem, x squared plus y squared, all that good stuff. And yeah, then we will work out the exact length of the chord, okay? So once we work out A and B, it's like, think of like the right angle triangle. Work out, you're going to have a horizontal value, a vertical value, Pythagoras theorem, that will give you the length of the chord. So that's effectively what we are working out, okay? So if I can erase this now, let's just work this out in equation form first. So let's just think about what we have. So we have y equals 2x plus 5, and we have x squared plus y squared is equal to 20. So therefore, if we make these equal to each other, therefore we have x squared plus, now instead of y squared, let's write in the substitution of 2x plus 5 squared. So now they're equal to each other, and that's equal to 20. I'm just going to expand the brackets out, so we get x squared is equal to a 4x squared. Then we get 2x times 5, which is 10x, and then another 10x, so we get a 20x. And then we get a 5 times 5, that's 25, and that's equal to a 20. Therefore, we get a 5x squared plus 20x, and then that would be a positive 5, that is equal to a 0. Therefore, we get x squared plus 4x plus 1, that is equal to a 0. Now, this question, again, we can't factorize normally, so let's either going to use a quadratic formula or complete the square. I'm going to complete the square, so therefore we get an x plus 2 squared minus a 4 plus a 1 is equal to 0. X plus 2 squared minus a 3 is equal to a 0. X plus 2 squared, therefore, is equal to 3. X plus 2 is equal to a plus or minus the square root of 3. Therefore, our x value is equal to a minus 2 plus or minus the square root of 3. So it worked out that our value is a minus 2 plus or minus the square root of 3, okay? So those are our 2x coordinates. Now we want the coordinates. In the question, it wants us to work out the coordinates in third form as well. So this is our x value first. Let's work out our y value now, okay? So we know that if we use this straight line, that's the easier one to use. We know y equals 2x plus 5. If we first, let's put in the minus 2 minus the root 3 first, okay? So we do y is equal to a 2, and then a minus 2 minus the root 3, okay? And plus 5. And if we work this value out, what do we get? Well, we would get a minus 4, okay? Minus a 2 root 3 plus a 5. So that y value would simply be a 1 minus a 2 root 3, okay? And let's do the same thing for the positive value now. So now we do y is equal to a 2. And now we'll do the other value, which will be a minus 2 plus. So minus 2 plus a root 3 now. And that's still plus 5. And this would be a now minus 4 plus a 2 root 3 plus 5. So we get a 1 plus a 2 root 3. So what does this mean? This means our coordinates would be, so one of the coordinates, it would be a minus 2 minus root 3, and then it would be a 1 minus 2 root 3. That is one of our coordinates. and the second coordinates would be a minus 2 plus root 3, and then a 1 plus a 2 root 3, okay? Okay, so now I worked out our coordinates. Then what do we know? Well, we know that A, in my case, where my A is, okay, we know that that must be the point of a minus 2 minus root 3 and a, what was it? It was a 1 minus a 2 root 3, okay? It has to be down there because that's where the negative quadrants will be. And up here would be the minus 2 plus root 3, and that would be the 1 plus a 2 root 3, okay? It'd be something looking like this, okay? So now that we've worked that out, well, now to look at the exact length of the chord, if I just draw a little triangle here. Okay, all we need to do is now work out the difference, okay? You just need to work out the difference now of the change in y and the change in x, because what's the difference? So don't know why I did my brackets like that. Let's just do my brackets a bit better. So that was a 1 plus a 2 root 3. Okay, so again, all we need to do is work out now. So let's start with the x values, right? Well, we have a minus 2 plus root 3, and that will be minus the minus 2 minus a root 3, okay? So let's actually just work that out, okay? So if we work this out, then what does that look like, okay? So if we have a minus 2 plus a root 3, and then we minus the minus 2 minus a root 3, well, let's work this out. So minus 2 minus a minus 2, that is just 0. And then a root 3 minus a minus root 3 is a root 3 plus a root 3. So that will give me a positive 2 root 3. So we know that this value here is 2 root 3. And then we do the same for the y values. So we get a 1 plus a 2 root 3 minus a 1 minus a 2 root 3, okay? And then we do the same thing. So we get a 1 minus a 1 is a 0. And then a 2 root 3 minus a 2 root 3 is a 4 root 3. So that this would be a 4 root 3. Therefore, Pythagoras' theorem, to work out the length now, the chord, it would simply just be a 2 root 3 squared plus a 4 root 3 squared, okay? And then that must be some value. Let's call this value, let's call it, what should we call it? Let's just call it x, okay? It doesn't really matter. X squared, okay? So therefore, what's 2 root 3 squared? That is a 12. 4 root 3 squared, that is 16 times 3, that's a 48. That's equal to x squared. So therefore, we have x squared is equal to a 60. Okay, and therefore our x is equal to a root 60. And if we write that in third form, that would be a 2 root 15. Okay, so we worked out everything we need to work out. We have the coordinates here, 2 coordinates. We have this coordinate here. We have this coordinate here. And then we have the exact length of the chord, 2 root 15, which is here. That is everything they wanted to know for that question. So for this question, we have a straight line through the point 10, 0 with gradient m is a tangent to the circle. Find the 2 possible values of m. So for this question, what are they asking about? So if I draw my circle here, okay, let's just move it down a bit. Okay, so we have this circle here, and it's the same circles, so we know that we're still going to have a center of 0, 0, okay? And we are told that a gradient m, we don't know what the gradient is a tangent to the circle, and it goes through the point 10, 0. So if we think about it, well, if the center is 0, 0, 10, 0 would be just horizontal, it would just be to the left by 10 units. We know that from the previous question, we know that our radius is root 20. So we know that it's root 20, okay? We know that root 20 is going to be less than 10. Therefore, we know that 10, 0 will be outside the circle. And let's say it would be here, okay? Let's say this point here is 10, 0, okay? Therefore, what they're saying is there is some type of tangent to the line. So let's say it's there, okay? And we have another one here, okay? We have it on this side here. Now, why do we have 2? Because it just says that a straight line through the point 10, 0 with gradient m is a tangent to the circle. Find the 2 possible values of m. Well, there are 2 straight lines which could potentially be a tangent to this circle, okay? We could have one here, and we can have one here. Okay, these are the, and whatever those gradients are, they will be the 2 possible values for m. Okay, so how can we work out what this gradient is? Well, what we can do is, if we think about the equation of a straight line, right, is y take away y1 is equal to m x take away x1. Well, we actually have everything we need except for the m value, right? Because we know that it goes through the point 10, 0. So we know that in this case, we have x is equal to 10. We have y equal to 0, but with m, we just have m, right? So if we think about what can we do? Well, if we think about an equation we can do for this, therefore, if we just formulate an equation in terms of m, we would get a y take away a 0 is equal to an m x take away a 10. Therefore, that would be y is equal to an mx minus a 10m, okay? And therefore, now we have an equation for that straight line in terms of m. And now we can put this into our equation, okay? Put this into that circle equation. So remember from the previous question, the circle equation was x squared plus y squared is equal to 20. We can put that equation in for our y value, and once we do that, there's something which we can do, which I'll get onto. So first things first, let's put it into that equation. So again, we have an x squared plus a y squared, okay? In this case, a y squared would be an mx take away 10m all squared is equal to 20, okay? Now we're going to expand the brackets out, and we should be left with some type of quadratic equation in terms of m. So let's do that. So we get x squared plus a m squared x squared. Then we would get a m squared x, and we get another m squared x. So we get mx times a minus 10m, which is a minus 10m squared x, minus another 10m squared x, will give me a minus 20m squared x, and then positive 100m squared, and that would give me a 20. Bring everything to one side, and I'm going to start to factorize as well. So we get an x squared, so then we do it the other way. So we get a 1 plus m squared x squared. So I've just taken my x squared and my m squared x squared, and I've factorized it now with x squared being outside. And then we get, I'm going to do plus minus 20m, okay, and that is also minus 20m squared, and that's also going to be times by x. And then we have the 100m squared. I'll just do brackets around that as well. My bad, that'll be minus a 20. And then that will be equal to 0. So what I've done is I've brought everything to the left side, and I've just factored out what I can to get all my x squares together, my x together, and my constant values together. And why have I done that? Because now we have it in the form of a quadratic equation. So why is that important? Because if we go back to this graph here, okay, well, what do we know about these two values here? Well, we know that it doesn't matter what tangent is the correct m value, okay? It's only going to intersect the circle at one point. Only ever at one point. And if something intersects at one point, right, then we can look at that in terms of the discriminant, okay? If something has one solution, now it doesn't matter which point it has, because this is the key. You may think that it intersects at 2 points, but no, these are two independent lines. If you just look at one of these lines, let's say this line, right? This line is only going to intersect at 1 point. And this line will only ever intersect at 1 point. These are independent lines. Therefore, with the discriminant, it will just be b squared minus 4ac is equal to 0. Now, the reason why we get two solutions is due to the fact that we have m squared. Now, that m squared, that's where we're getting the two solutions from. But we can use the discriminant of b squared minus 4ac is equal to 0, because each of those lines, each will only intersect at one point on that circle. Therefore, it will only ever have one solution. Therefore, we can use b squared minus 4ac to work out what the value of m would be, which is our gradient. So if we do that, in this case, we have a is equal to 1 plus m squared. We have b is equal to a minus 20m squared. And we have c, which is equal to 100 m squared minus 20. If we put that into the formula, what do we get? Okay, so we would get a minus 20 m squared. Okay, that's all being squared. Now we get a minus a 4 times an a, so we get minus a 4 times a 1 plus m squared, and times by c, which is a 100 m squared minus 20. Okay, and this all must equal a 0. Okay, now if we expand everything out, we would get a 400, a positive 400 m to the 4, and then we get a minus 4, and I'm going to expand the brackets out first. So we get a 100 m squared minus a 20, and then we get a plus 100 m to the 4 minus a 20 m squared, and that is equal to 0. Therefore, we get a 400 m to the 4 minus a 400 m squared plus 80 minus a 400 m to the 4, and then we get a positive 80 m squared, and that is equal to 0. As you can see, our m to the 4s will actually cancel out, so this cancels out with this, so that's good for us. Therefore, we have a minus 400 m squared plus 80, so that would be a minus 320 m squared plus 80, and that is equal to a 0. And therefore, we have 80 is equal to a 320 m squared. Therefore, m squared is equal to 80 over 320, which is 1 over 4. Therefore, if we have m squared as 1 over 4, therefore m must be the square plus or minus the square root of 1 over 4, which is a half. Therefore, we have our two values now. It's plus or minus a half, and that does make sense. That means that the gradient for, let's say, this line here, the gradient for this line would simply be minus a half. The gradient for this line would be a half. And yeah, those would be our two values for m. So our two possible values is plus or minus a half. Okay, so for question 10 now, we have that the curve has equation y equals f of x, and it is given that f dash x is equal to this equation here, where k is a constant. The curve has a minimum point of x is equal to 2. Find f dash dash x in terms of k and x, and hence find the possible values of k. Okay, so why is this significant? How can we work this out? Okay, so first and first, let's work out f dash dash x first. So we can differentiate s dash x again. So if we think about differentiating that, okay, well, what would that be? Well, if we think about it, what would we get? Well, we would take a half out, okay, and then we'd times by that minus 2. So that would be a minus 1. So we get a minus on the outside, and then in brackets, we get a half x plus a k, and that'll be to the minus 3. And for that 1 plus k to the minus 2, well, that's a constant value, so there's no x's involved in that, therefore it just cancels out. So this is what we're left with f dash dash x. That's the first bit. But we want to find the possible values of k. Now, how can we do that? Well, they tell us in the question that the curve has a minimum point at x is equal to 2. So what does that mean? We're thinking about minimums and maximums, right? Well, if we have something like this, so if we have f dash dash x, okay, and we know that it has a minimum point, well, we know that f dash x, when that is greater than 0, then it has a minimum point, okay? So if we, let's write that, minimum. So we know that if you have a minimum at x equal to 2, we know that in this case, f dash dash 2, because that's the stationary point, so we know that f dash dash 2 has to be greater than 0. and therefore we can use that and we can substitute in 2 for k, make it greater than 0, the equation, and that should give us the possible values of k. So let's do that. So if we do that, we get a minus a half times a 2. So that will be 1 plus a k, okay, to the minus 3, and that has to be greater than 0. Now, if we bring that minus to the side, okay, it's going to flip the inequality. So we end up with a 1 plus k to the minus 3 is now less than 0. And now for this one, well, just looking at that, this means that if we have any value and we put it to the power of a negative 3, okay, if we want it to still be a negative value, then 1 plus k has to be a value less than 0. So therefore 1 plus k is also going to be less than 0. Therefore k has to be less than 1, which makes sense because you think about it. If k was minus 2, for example, then then you get 1 minus a 2, which is a minus 1, and that would still give you a minus 1 value less than 0. And if you keep getting any value less than minus 1, then yeah, you're going to get a negative value. So we know that k, the inequality or the values of k is just values which is less than minus 1. So for part B, it is now given that k is equal to minus 3 and the minimum point is at 2, 3 and a half. Find f of x. Okay, so we know what f dash x is. They tell us that in the question. I've written it here. And so all we need to do is integrate and then put in our values that can help us work out our c value, our constant, and then that should be our equation. They tell us now what k is, so we can substitute that value in for k. And just one thing, I'm going to rewrite the coordinates they give us as an improper fraction. So I'll write it as 2 and 7 over 2 because that'll be easier later on when it comes to working it out. But first thing first, let's just change this. Let's put in our value for k. So we get f of f dash x is equal to a half x. Now k is equal to minus 3, so it'll be minus 3. And that is to the minus 2 minus 1 minus a 3, so that'll be minus a minus 2 to the minus 2. Therefore, f dash x is a half x minus 3 to the power of minus 2. Now, minus 2 to the power of a minus 2, that is just a positive 1 over 4. So it'll be minus 1 over 4. Okay? So let's start integrating this. So we get an f of x. Okay? So we get that half x. Now, if we think that half will come out and then we do the reciprocal, so we know that a 2 would be on the outside. And that would be a half x minus 3. And then minus 1 here. And then we minus 1 here. And then for that quarter, we just need to add the x. Okay? And then this will be a plus c. And if I just simplify this down a bit, we get a f of x is equal to a minus 2, and then we get a half x minus 3 to the minus 1 minus a quarter x plus c. And now let's put in our values. Okay, so we know that 2 and 7 over 2 were our values. Let's put those in. Let me go to the other page. Okay, so if we do that here, therefore, what do we get? Well, we get a 7 over 2. Okay, that is equal to a minus 2. And then in brackets, it was a half. And then x, so x is just 2. And then minus a 3 to the minus 1. And then that's that. And then we have minus a quarter x. That'll be minus a quarter times 2. And then we still have the plus c. So we get a 7 over 2. Then that would be a minus 2. And then that would be a 1 minus a 3 to the minus 1. And then we get minus a half plus a c. So therefore we get 7 over 2 is going to be a minus 2. Then we get times by a 1 minus 3, which is a minus 2 to the minus 1. So that's minus a 2. Let's do it in one go. Minus 2 times times a negative half. Okay, and then that is also minus a half plus c. So we get 7 over 2 is equal to a positive 1 minus a half, okay, plus c. Therefore, if we work this out, we get a half, we get a 6, we get a 2, so we get c is equal to a 3, okay? So now that we get c is equal to 3, therefore, we need to rewrite this equation now. So what would that be? It would be a. Now, we can actually rewrite this as a minus 2, and then in brackets, we can have a half x minus 3 to the minus 1 minus a quarter x, and then add your constant, which is just 3. So this is the last question now. We need to find the coordinates of the other stationary point and determine its nature. So in the first part, they told us that the stationary point was 2. There's going to be another stationary point, which we need to now work out, and we need to determine the nature of that. So as we get any stationary point, it's f dash x is equal to 0. And for us, f dash x was a half x minus 3 to the power of minus 2 minus a quarter, and that was equal to 0. And what they're saying is that we should get two values for x when we do this. One of them should be 2, which we already know, and the other value, that will be the other stationary point value, and then just determine its nature. So determine if it's a minimum or a maximum, okay? So let's work this out. So if we get a half x minus 3 to the power of minus 2, that's equal to a quarter. Then what I'm going to do is I'm going to do a half x minus 3 to the minus 2. I'm going to raise that all to the negative half. That will cancel out the minus 2 and it'll become a 1. And we have to do the same thing on the right side, so that'll be to the negative half. Therefore, we end up with a half x minus 3. And on this side, it will be plus or minus still, because now we're going to do the square root. So obviously before, I guess, because before we are square rooting, but we're still going to do the plus or minus. We just have the negative as well. So it'll be plus or minus the square root of 4, which is 2, okay? So we worked that out, so that's that one done. And now that we've done that, it's a half x minus 3 is equal to the plus or minus 2. Okay, I just rewrote the same thing. Therefore, that is just a half x is equal to 3 plus or minus 2, which is half x. So that's x over 2. So that will be a 2 times a 3 plus or minus 2. Okay, and those two values, if we work that out, well, we have one value which would be 2, and then a 3 plus a 2. That would give me a 10. Okay, so we know that the other stationary point is a 10. And just on the safe side, let's work out the other stationary point, and this should give us a 2. So that would be 2, and then a 3 minus a 2. And then, yep, that will give us a 2 times a 1, which is a 2. So perfect. So we worked out our stationary points. We know we've done it correctly because using these two, we've got our two values of 2 and 10. And we know that one of our values should be a 2. So that's good. So now we've got our stationary points as x is equal to 2 and 10. Well, we already knew 2 was a stationary point, so we care about the 10 now. So when x equals to 10, we need to work out, is that going to be a minimum or a maximum, okay? And that is what we want to figure out. But first things first, in the question, we want to work out the coordinates. So let's just work out that value first. So look at the value, it will just be, put that into our f of x, okay? So f of 10, what would that be? That was a minus 2, and then it was a half times a 10 minus a 3 to the minus 1, okay? And then that was minus a quarter times a 10 plus a 3. So if you work all of that out, okay, you will get a minus a half. Okay, let's put it into calculator, you get minus half, so we know that the coordinates would be 10 and minus a half. Okay, and now that's the coordinates. Now determine the nature of it. Well, the nature is pretty much we need to put in the value of f dash 10 and see what that value is. If it's greater than 0, it's going to be a minimum. If it's less than 0, it's going to be a maximum. Okay, so if we work that value out, well, f dash 10, what would that be? That would be minus a half times 10, and then we had plus k, so k was a minus 3, so we're still taking that as minus 3, and then that was to the minus 3. Okay, so if we work this out, we get a minus a 5 minus a 3 to the minus 3, okay? And then that is a minus 2, okay? And that's to the minus 3, which would give me a minus 1 over 8, okay? So now we get a minus 1 over 8. Well, minus 1 over 8 is less than 0. So because a minus 1 over 8 is less than 0, if it's less than 0, it's going to be a maximum point, okay? So therefore, we know that this is going to be a maximum point, okay? So therefore, we worked out the coordinates is 10 and minus a half. We've worked out that when we put that into this second derivative, we get minus an eighth. Therefore, that's less than 0. Therefore, it is a maximum point, and we have done everything we need to do, and that is the end of the paper. So hope you enjoyed this. This paper wasn't too bad, but each question was pretty meaty. So as you can see, there's only 10 questions in this paper. But overall, it wasn't the worst exam. I think that maybe question 9, I think question 9b was a bit of a tricky one if you didn't know to rearrange that to get your mx minus 10m. So that could be a bit tricky. But other than that, it was a fairly okay paper overall. So yeah, I hope you enjoy this. In our next video, we'll be doing the 2022 variant 1, pure 1. So stay tuned for that, and I will see you soon.